welcome to all. We are almost reaching the end part. Today is question 101, that is lecture number, I forgot actually, 98 I think most probably. One more lecture required, that is next class. I will close this steel structures part. So this today's class meant for 4 angles. See, sometime in a construction you can see one angle here, one angle here, one angle here, one angle here. Of course, they are all properly connected by lacing or battening. Then only it will behave like a single unit. So 3 questions are there. One question is for equal angle. See, here it is 150 by 150. First question. Second question is unequal angle. Third question also is unequal angle. Unequal angle, 2 cases. Placing of the angle. Sometimes the longer leg can be vertical. See, you can place with the longer leg vertical, or unequal angle, you can place shorter leg vertical. So this I will cover next 2 questions. All 3 questions are important for understanding. And moreover, if you study all these questions for steel structures, your knowledge will improve. Okay. The cross section of a steel column consists of 4 angle sections, 150 by 150 by 15. See, 150 by 150 by 15 means, see here, 150, 150, thickness is a line diagram. Thickness is 15. Placed at the 4 corners to form a square section of side 440 mm. Okay, this is a question. Find Ixx, Iyy. In the question given, properties are area, Cxx and Ixx, Cyy, Iyy are equal, property given. Okay, I will explain that one. See. Now, first, cross sections here. I drawn the angle as neat as possible. 4 angles. See here, this is 150, not required for you. 150, 15. Same for all the 4 angles. They told to form a square section of side 440. See, this is 150. This is 150. 150 plus 150 is 300. So they told side of the square is 440. Therefore, if you calculate, see, this gap, it is not required. This gap and also this gap, it is not required for us, is 440 minus 150 minus 150 will be 140. This also is 140. Okay, now you should make a note. In the question, it is possible that instead of giving to form a square section of side 440 mm, they can give this statement. This statement they will not give. In the sketch they will give you here, see, 140, 140. In that case, what you do? 140 here, 150, 150, total 440, total 440, get that one. So, if they give the overall dimensions, directly you mark. If they give between them spacing, then this total side equal to this gap given plus this side. That you write here. Now, properties of the angle. Our angle is ISA, means Indian Standard Angle. Okay, don't worry too much about it. 150, 150 by 15. See, angle is placed in all the handbooks. See here, one angle is placed this way, one angle this way. But IS handbook, when they give property, they always give sketch like this. If it is a turn, you turn it, they will tell. When you read the property, you see the which is correct. So see here, 150, not required, 150, 15, 15. It is a single unit. This is the centroid for that one. See. Now, this distance is called Cxx, centroidal distance of xx axis. This distance is called Cyy, centroidal distance of yy axis. They told area, complete area is 4278 mm square. This Cxx equal to Cyy, 42.6 millimeter, and Ixx equal to Iyy, 896.8 10 to the power 4 millimeter power 4 given in the question. Here sketch is not given. Here with the sketch. Okay, now start. As usual, always first find area. Actually, very easy. Total area. See, 4278 is area of one angle into 4. See, I will take 1, 2, 3, 4. You need not work out all the 4 parts. Consider one part. Okay, over. Now, very important, IXX, see here, IXX. But before that, remember, usual, see, usual statement, red color I will tell. Now I won't explain. Question number 101. Class number we are approaching, lecture number, century you are approaching. So it is your problem. What moment of inertia about any axis equal to Ig plus A square, what is the meaning? That all you have tried. No one should ask, we is not explaining what is the meaning of moment of inertia. Too late. We are near the end portion. Again I told, study, see, this is part F I think today. You start from part A of this classes dedicated to steel structures, not directly come here. Okay, start. IXX, come here. See, G1, G2, G3, G4. See there? Now, first see among the four angles, see which angle is correctly suited here. Best angle is this angle, 1. Why? Because see, the placing is exactly same. So see this angle. But answer is same for all the four angles. But anyway, see this angle. See, I about its own centroidal axis parallel to x-axis. This axis. I about this axis is, see here, I about this x-axis axis 896.8. 896.8 10 to the power 4 is Ig plus area of this angle. How much it is? 4278 is the area multiplied by what? Square of the distance from centroid of the angle to required axis. See, this distance square, that distance square is, see, if this is 440, this is 220, 220. Same way, 220, 220. See, we want this distance square is 220 minus this distance. See, so it is 220 minus from here up to here. This distance is, see here, this distance, how much? 42.6 minus 42.6 whole square is IXX for one angle. Now, that's all. See, even here also, same Ig plus same A square, same Ig plus same A square, same, all four are symmetrically placed, multiply by 4, you get the answer. Now, IYY, don't waste time, because see, all are equal angles. All sides are equal. So here, if you turn, nothing will happen. Your IYY will become equal to IXX. So copy that answer. Whatever you got, copy it. This is question number 101. Okay, now I will go for 102. See, the cross section of a steel column consists of 4 angle sections ISA. See, 125 by 75 by 125 by 75 by 10. This angle is there in the handbook. Placed at the 4 corners. No, see, this is not there. Placed at the 4 corners. See, as shown. Now they should show a sketch here. As shown. See, one angle here, line diagram. See, 125 by 75. One is the larger side, other is shorter side. See here. Then this way. It's shorter. Okay, this way side. Now they will give you, I am going to give you what is this distance and this distance. In the question I am giving. See, this is around say 160 millimeter, this one. This distance is 125 is already there, 110 millimeter. It is given in the question. Okay, now properties of the angle given. Area I will give it for you. CXX I will give you. CYY also will be not the same. I will give CYY also. IXX I will give you, and also I will give you IYY in the question paper only. See, in the question only, this will be given. Okay. 1 minute. Here, It is possible for some people to avoid confusion in the question. See, if it is steel structure, people are knowing, but otherwise, to avoid confusion, they may give one line diagram here. See this way. See. And then they will tell you, this is XX, this is YY. This way they can give. Okay, little turned actually. Okay. I'll show it here. Those who are studying engineering mechanics, one sketch will be given here. XX, YY, they will tell this is your CYY, this is your CXX. They may tell that way, little turned actually, okay, no problem, adjust it. This is centroid G. They may give it or may not give it. Okay, now sketch out change. Start now. Question already told. Properties are given here. See, find IXX, IYY. See, I told you they can give they are given 160 here, 110 here. See now. When you write the main sketch, see, ISA 125/75 by 10. See, you can make out in the sketch, longer leg is vertical, shorter leg is horizontal. See here, longer leg vertical, shorter horizontal, longer vertical, shorter horizontal. Or, instead of giving sketch, they can tell by words. What they will tell? 4 angles, 125/75 by 10, placed at the four corners with longer leg vertical. They can give that way. Vertical means in the paper plane. Actually, everything is horizontal because it is a plan. Okay. In the placing, longer leg vertical as per this sketch, YY. Okay. Or, now, see, this is 75. You can do one thing. Once the sketch is given, you write this sketch once again now. At that time, we want the total length here. See how to get 75. See, this is 75. This is 125. So, this total length is 75 into 2. See, 75 into 2 plus 160 clear. That will give you 310 millimeters. See, I marked the 310 here. And total vertical distance, where to write it here? Here. You mark the total vertical distance. See how much? 125 plus 125. So this is 125 into 2 plus 110 extra. That will give you 360 millimeter. 360. So this is 360. Or make a note, in the question, they may not give 160 and 110. In the sketch only they will tell you 310 and 360. Either they will give you the clear distance, then you find the outer distance, or if they give outer distance, thank you, we want outer distance only. Okay, now, see, everywhere longer leg vertical, shorter leg horizontal. You can observe one thing here, see, centroid, here more area is there, is more this side. See here CX area is 1902. CXX from here to here is 41.4. From here to here is only 17.5. So everywhere, see here, centroid will be, see, this distance is your CXX, CYY, this is CXX. Exact scale is not maintained. Okay. Mark centroid, just mark centroid. Exact scale not required. Okay, start. Now, XX axis here, YY here. Full symmetrical. So, YY will be 310 means 310 by 2, 310 by 2. 360 means 180 by 2, 180 by 2. But this time remember, IXX is not equal to IYY. Make a note. No, first area. Area equal to Y waste time. 1902 is area of one angle. Multiply by 4, you get the area. I am just checking the camera. Is the bottom visible or not? 1 minute. Oh, visible, no problem. Okay. So, area is over. Don't waste time on area. You calculate later. Everything you have to calculate later only. So, area over. Now, important is IXX and IYY. See correctly now. I about xx. Usual story you have to write. I about any axis equal to ig plus a square. That all if you cannot write and if you don't understand, no point in attending my class. Okay, start first. I about, see, among the four angles, see which angle is exactly placed as per the property page. See, this is the longer leg, shorter leg, this way facing. Oh, yes. Angle number 1. So consider angle 1 for reference. Then identical for all. See now. I about its own centroidal axis first. See. This axis is parallel to shorter leg here. See. This axis. That axis is exactly same as this axis. So I about this axis is, where is it? 300.3 10 to the power 4 plus area 1902 into from centroid G1, see correct clear now, centroid G1 to XX, see this distance square, that is 180 minus this distance, see that G1 from the edge of the shorter leg, this distance, see here, oh that is exactly this distance, how much? 41.4 minus 41.4 square into 4. Why? Identical all the 4. If you calculate for this also, same answer will come. See, once again when you draw axis here, it will be same axis, not required. Into 4. Now, I. Start here. Again this angle, see. First, I about its own centroidal axis, parallel to YY. See, YY. This axis. This axis is parallel to longer leg. See, oh yes, it is same as this axis. I about that axis is 81.6 10 to the power 4. I written here 10 to the power 4 plus area 1902 into from centroid G1 to this YY, see this distance square, that is 155 minus this distance from the edge of the longer leg, see this distance, that distance is exactly, see this distance CYY is 17.5 square. Multiply by 4, you get the answer. Okay. Now, to give you more idea and clarity, what I will do is, question number 103, I will maintain same angles. Okay. To give more clarity, I can change the angle. No, terms will interchange now. So, the cross section of the steel column consists of 4 angles ISA 125/75 by 10 placed at the 4 corners as shown in the figure. Okay, now see, figure I will write here. Now the scale problem is there. I don't want to change that scale. Okay, see now, place 4 corners. I will use the same sketch, so I won't write once again how much it is. Last time I told, I forgot the distance. Okay, I remember. Okay, I will give overall this time. Okay. See, this way. This overall dimension is given. How much? I will give same 310 to understand. Don't calculate. New question. This is 360 required. 360 means 70. Okay. This way. This is the 4 angles. See here. You can observe something here. See, now they are giving in the question, this distance is they are giving 360 in the question. Or make a note. This or instead of giving 310 and 360, see now they are already told 310 here, 360 here. I maintained same as last time to save time. Okay. And also to understand the terms here. Terms will get interchanged. That's why. But still, or see, they may not give 310. See, they will give this distance as, it is 125 is what? 250, 60. And this distance they will tell total how much? 360 minus 2 into 75 is on. 360 minus 2 into 75 is 210. See. Now make a note here. They may not give 310 here, may not give 360 here. They can give this way, out of scale now, out of scale. Don't see the scale now. I don't have time for changing everything. they can give this way. Then, see, this is the longer leg. Or in the question they will tell longer leg placed horizontal and shorter leg placed vertical. So, if this is 60, this will become, see, 60 here plus this is the longer leg, 125 plus another 125 here. It will become 125 into 2 plus 60 is 310. It will become 310. Same answer. And this height, this will become so much 210 gap plus, see, this is a little out of scale. Okay, here this, okay. 210 gap plus 75 plus 75. 2 into 75. It will come 210 plus 2 into 75. 360. Okay, 360. Okay. But actually remember, they can give, make a note. But in the question, see, they told corners as shown below, as shown in the figure, then they told this distance. They are given how much? Directly. I told this is given 360. This is given how much? 310. This is given 310. This is given 360. Out of scale. Okay, then. Okay. Property is given. But remember, when the property is given, always property will be given for you when the longer leg is placed vertical. Don't see here. Because IS handbook does not know whether you are placing the angle, see, whether you place the angle like this or angle like this, unequal angle, IS handbook does not know. So, IS handbook will always print the property. You write here. See, this is from IS handbook. Write a note here. IS handbook always will print the properties considering longer leg vertical. See, this is a longer leg, this is a shorter leg. This is a rule. Everywhere, throughout the world, same rule they maintain. So, these properties are given here. See, these are, we can make a note here. All these properties are for this sketch. Means when the longer leg is vertical. Okay, now I'll change the sketch slightly and go for last part. 10 minutes more. Over. Now today's concluding part, today's a small class. See, everything over. I explained all these properties. First area. What is area? 1902 into 4. Area will remain same. Okay, now very important. See here, x axis here. I marked the G1, G2, G3, G4. Actually, okay, slide. Right, 1 minute here. G4, little. Okay, G1. Okay, sir. Now, see here, everywhere I made, see here, longer leg, shorter leg, longer leg, shorter leg, longer, shorter, longer, shorter. Start. I about x axis. First, be very careful now. Come to component. See, first I about, see, its own centroidal axis, this axis. See here, this axis is center. See, this axis is not this axis. Be careful. See, this axis is not that x-axis, or this is the centroidal axis which is parallel to longer leg. See, longer leg here. See, from the longer leg parallel. So, this axis, longer leg here, this axis. For the longer leg parallel axis, see, it is this axis. So, that is I about YY. 81.6 will come here. See, this number will come here. 81.6 10 to the power 4. You should be careful. Let this coming. Okay. 81.6 10 to the power 4 is IG plus area into from centroid G1 to this distance. See, this distance square. That is 180 same. 180 minus not 41.4. See, 180 minus this distance from the longer edge to centroid, this distance. See, this distance is, oh, it is not this distance. See, this is the centroidal distance from the shorter leg, from the longer edge here to centroid. See, this distance. See, this distance here is, when you go there, it is this distance. How much? 17.5 millimeters. See, change now. 17.5 whole square. Okay, into 4. Now, I about yy. First come here. I about its own centroidal axis. This centroidal axis is not this centroidal axis here. This centroidal axis is parallel to shorter edge. Parallel to shorter edge. This is the centroidal axis. So, see, this axis is, see, shorter leg. This axis is this axis. That is 300.3 10 to the power 4. It is you should not copy this way. You should make this as an independent question. Do not see last time question, but compare it. Plus area into, see, from centroid G1 to YY, see, this distance square, or see, this distance square. That distance square is 155 minus, see, minus, see, this distance. 155 minus this distance. This distance is not this distance, because why? This is the distance from the shorter leg, but this is the distance from longer leg. So, see here, this distance is centroidal distance from the shorter leg. This distance is this distance from the shorter leg. It is CXX. How much? 41.4. That is the important. 41.4 square. So, whenever a rolled section is placed as per the handbook, then there is no confusion. See, when you do IG here, when you do XX, whatever is IXX there. When you do about YY, whatever is IYY there. But in case it can be for I section, angle section, or channel section. Next class is coming. Channel section, when I do gantry girder, our handbook will give channel like this. But in the gantry, it is placed like this. Next class, tomorrow's class, next class, last class. So that's the last question, big question it is. So make a note, whenever the placing of a rolled section is as per the property sketch or how the property is given, if the orientation is same as that one, then when you do IXX, it is that XX only. When you do IYY, it is that YY. When you want this distance, it is this distance only. When you want this distance, it is that distance only. But in case the rolled section is placed turned in not as per orientation, turned by 90 degrees, horizontal there becomes vertical here, vertical there becomes horizontal here, then when you want IXX, it is YY property and this distance. When you want IYY, it is XX property and this distance. That you should know it. So that's why I took the same angle, one so that property remains same. But see here, this last time 81.6 was here, 303 was there, and 17.5 was here, 41.4 was there. Now study all the three questions correctly and make a fair copy and write all the notes, explanation I given in your own words. Now next class is the last class where I will consider the cross section of a gantry girder where there will be an I section. See, this is a very popular gantry girder in factory buildings for the cranes, gantry cranes. You are using it. That I will explain the steel structure. I will put a plate here to understand more, and here I will put a channel. See, over this channel there will be rails. See, rails will be there. Over the channel, rails will be there, and over the rails some sliding arrangement is there. A cross girder will come and connect, where from one place in the factory shed you can transport anything to wherever you want by moving the crane girder and crab. That's all not required for you. Our question is an I section, a plate and a channel section which is turned. See, channel properties like this in the handbook, it is turned. Or this is the last question. 104. Next class, last question is 104. So that 104, I will close this moment of inertia calculation for dedicated to steel structures. I will once again come back to rectangle, triangle, usual. So this dedicated to steel structures is important for those who are serious about steel structures. And in engineering mechanics exam also such questions can be given. It can be given. They will tell the property I am giving, you calculate. Okay. We'll meet in the next class. Thank you very much.